In this section, we're going to learn how we can solve trig equations and inequalities using graphing utilities. And basically, the issue is, some equations or inequalities cannot be solved analytically. That is, using algebraic or trigonometric techniques and identities. And so we have to have some other approach. Now, of course, the graphing calculators that we have access to have tools on them that help us to do these things. We just have to learn how to use them correctly by using the points of intersections of two curves. You should have learned the basic concept for this in an earlier course, intermediate algebra or college algebra. But if not, I'm going to show you how in this course as well. So for example, if we wanted to solve the equation sine 3x is equal to 1/2 x minus 1. See, now the real issue is this 1/2 x term. See, this algebraic term, this 1/2 x, causes issues. If it was just sine at 3x equals -1, we know how to solve that. Because the sine, it takes the value -1 at specific values that we know. That 1/2 x messes things up. Basically, once we combine that trigonometric term with an algebraic term, it's almost always impossible to solve. Analytically, that is. So what I'm going to do is I'm going to solve this graphically. I'm going to use the calculator and I'm going to graph two equations. I'm going to call the y1 sine of 3x, and I'm going to call the y2 1/2 x minus 1, and I'm going to find points of intersection. And then I'm going to use those points correctly. And that last part is often where students make a mistake in using the points correctly. So let's remember that if we were just solving this equation, just forget that it's trigonometric, or forget that we don't know how to solve it. If we were going to solve it, the solution or solutions are the x values that make this a true statement. So the solutions are just x values. The solutions are not ordered pairs, just x values. So we're going to get points of intersection. We're going to get ordered pairs. We have to learn how to use them correctly. So let's do this. I'm going to bring up my calculator. So there's my TI-84. Now if you have a different calculator, it's going to work a little bit differently, but you should be able to figure it out. I'm going to go, let me check my mode. I must be in radian mode. If I'm not in radian mode, I'm not going to get the correct solutions of this equation. I go to my y equals screen. y1 sine 3x. Close that off. Hit enter. y2 is 1/2 x. Subtract 1. I'm going to graph this in the standard window to start, and then maybe adjust it if necessary. Let's start in the standard window. So remember, to get to the standard window, we can just hit zoom in the 6th option. There's my sine 3x curve. There's 1/2 x minus 1. It's a linear function. And so it looks like I've got some action in here, maybe between -5 and 5 on the x's. And for the y's, let's go from -2 to 2. So I'm going to adjust my window manually. I want to go from -5 to 5 on the x-axis and -2 to 2 on the y-axis. And let's regraph that and get a better picture of what's going on. There's the sine 3x curve, and there's the 1/2 x minus 1 curve. And what I see is the curve appears to intersect at 1, 2, 3 places. That means that there are 3 x values for which the y values for y1 and y2 are the same. there are 3 solutions to this equation. Let's calculate them. So I go into my Calc menu by hitting second and the trace button, and I bring up the intersect command. That's the 5th option. I'll hit enter. And now I need to tell the calculator where to look. I want to look at the first curve, being the sine 3x curve. So notice it says y1 equals sine 3x. I'll hit enter. The y2, the second curve, is the 1/2 x minus 1. I'll hit enter a second time. And then for the guess, just move your cursor near the point of intersection using left and right as necessary, and hit enter a 3rd time. So here's my first point of intersection. I'm going to try and drag this over to the screen. So there's my first point of intersection. But now remember, there were 3 points of intersection. There are 3 solutions. So now I need to repeat the process and find the second point of intersection. Let me go back into my Calc menu. 5th option. First curve is the sine 3x. Second curve is the 1/2 x minus 1. But now let me move my cursor over to the second point of intersection and hit enter a 3rd time. It runs, it brings up a second point of intersection. I'm going to drag this over to the screen. And finally, let's find the 3rd point of intersection. Calc, 5th option, move my cursor. The y1 is the sine 3x. The y2 is the 1/2 x minus 1. And then move my cursor near the point of intersection. Here's the 3rd point of intersection. And so here's my 3rd intersection. And I'll drag this over to the screen. So there are 3 points of intersection. Now remember, we were asked to solve graphically, and remember that the solutions are the x values, right? The solutions are the x values that make this a true statement. So, x is approximately, let's approximate to 3 decimal points, x is approximately 1.187, 2.113, and 2.972. Those are the 3 solutions that I can find graphically. And those are the only 3 reasonable solutions, because if you think of this curve, the line 1/2 x minus 1, it's going to keep increasing. And the sine curve, sine 3x, is just going to keep on moving up and down between -1 and 1. It can never hit the line 1/2 x minus 1 again. So there are the 3 solutions of this equation. So, in general, to solve an equation graphically, and this works for trigonometry, it works for any types of equations. We call y1 the left-hand side, y2 the right-hand side, find where they intersect. So here's another equation, sine of x plus 2 equals x squared minus 9. Now would be a good time to pause, try this one out on your own. All right, let's take a look at it. Did you pause to try it out on your own? All right, so like before, I'm going to call the y1 sine of x plus 2. I'm going to call the y2 x squared minus 9. Let me bring up my calculator. Go to my y equals screen. Let me clear out the old stuff. The left-hand side is sine of x plus 2. Close that off. The right-hand side is x squared minus 9. And let me go back to the standard window. So I'm just sort of understanding sine of x plus 2, that's a curve that's going to move up and down. X squared minus 9, that's a parabola opening up. That's what I should expect to see. Let's graph it. And, sorry, I want to look at this in the standard window. So let me zoom 6 to get to the standard window. There's the sine curve. And there's the x squared minus 9. Looks like there's 2 points of intersection. So let me calculate them. Calculate intersect. And the first curve is the sine of x plus 2. The second curve is the x squared minus 9. And let me move my cursor. I'll go to the left first. My guess. So there's 1. All right, let me go back. Calculate the second point of intersection. Curve 1 is the sine curve. Curve 2 is the quadratic. And let me move my cursor to the right and get the second point of intersection. Alright, so using that information, and those are the only 2 points of intersection, I would write the solution. X is approximately negative 2.870. Again, to 3 decimal places, you'd have to round up appropriately. And positive 2.830. Alright, so that's basically how we would solve equations graphically. Now let's take a look at inequalities. Now, the process for solving inequalities graphically is pretty much the same as the process for solving equations graphically. The only difference is how we use those points of intersection at the end. And we have to be a little bit more careful because now we want where one is greater than or less than the other for an inequality. Not where they are equal, but now we're comparing them. So we start the same. I'm going to call the y1 the 2 sine x. Let me call the y2 the x squared minus 4. And really what I want is, I need to answer, where is the y1 curve above the y2 curve? Since it's a greater than inequality, where is the y1 above the y2? Let me bring up my calculator, clear out the old stuff. The y1 is 2 sine x. The y2 is x squared minus 4. I'm just going to graph that in the standard window. There's the 2 sine x. And there is the x squared minus 4. Now I'm going to grab this picture because I'm going to draw in it. So let me grab this and bring it down here. All right, let's go find those points of intersection. So let me find the first point of intersection. That's to the left. So x is approximately negative 1.422. Let me note that. Negative 1.422. All right, so this right here, this level, that is at negative 1.422. And then let's calculate the other point of intersection. All right, the y1 is again the 2 sine x. The y2 is the x squared minus 4. And let me get near and hit enter a third time. 2.334. All right, so this level right here, that's 2.334. Now, we want to know where is the y1 above the y2. And what I like to teach is I'm literally going to write on the curve where are the y1s and the y2s. Basically what I've done now is I've broken up the number line into 3 subintervals. I have a subinterval from negative infinity to negative 1.422, then from negative 1.422 to 2.334, then from 2.334 to infinity. So where's the y1? Well, the y1 is the sine curve, and the y2 is the quadratic. And over each of these three subintervals, I literally ask myself, where is the y1 above the y2? All right, so over the first interval, is the y1 above the y2? No. Over the second interval, is the y1 above the y2? Yes. So here, this is a good region. Over the third interval, is the y1 above the y2? No. So therefore, the solution is any intervals where I've shaded. Where's the y1 above the y2? The solution is the interval from negative 1.422 to 2.334. And again, this is an interval, not an ordered pair. All right, so over this interval from negative 1.422 to 2.334, the 2 sine x is greater than the x squared minus 4. Elsewhere, that's not true. All right, so here's another example of an inequality. 0.6x plus 1 is less than 3 cosine of 0.5x. This would be a good time to pause and try this one on your own. All right, so like before, I'm going to call the y1 0.6x plus 1. I'm going to call the y2 3 cosine of 0.5x. And I'm asking myself, where is y1 less than y2? Or where is y1 below y2? That's what I'm going to ask myself. Let's bring up the calculator, clear out the old stuff. 0.6x plus 1, that's my y1. 3 cosine 0.5x, that's my y2. I'm just going to graph it on the standard window to start. There's the y1, the y2. All right, and what I see is there's 1, 2, 3 points of intersection. Let me drag this down. So I see 1, 2, 3 points of intersection. So I need to calculate them. There's my first point of intersection. There's my second point of intersection. There's my third point of intersection. Let's calculate those. All right, so second, calc, intersect. First curve is the 0.6x plus 1. Let me hit enter. The second curve is the cosine curve. And let me scroll over to the left and get this first point of intersection. Hit enter. Negative 6.603. Let me find the next point of intersection. .6x plus 1 is y1. 3 cosine 0.5x is y2. And my guess, hit enter a third time, negative 4.208. And now the third point of intersection. .677. All right, so now, what's the y1? The y1 is the line. y1, 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 y1. The y2 is the cosine curve. y2, 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 y2. We want the y1 below the y2. So that happens, the y1 is below the y2 here and here. So over those two intervals. So therefore, I'll write the solution in interval notation from negative infinity to negative 6.603 union negative 4.208 to 1.677. Close it off. So that's how we can use graphing technology to help us solve equations and inequalities. And again, this skill is not only for trigonometry. You can use this skill with any type of equation in one variable. All right? Now go get some practice.